now. Okay, so the last thing we were seeing, what we were talking about last class had to do with shifts, vertical and horizontal shifts. And so we know that if we have a function and we add or subtract the value c to the whole function, that's going to generate a movement either up or down. And like Arturo mentioned, the hack, just remember that value that we are adding or subtracting is going to be the y-intercept. Now, if within the function we add or subtract a number, then we're going to get a shift left or right. And that shift left or right is going to be the x-intercept. Okay, so let's practice this. So I'm going to give you a couple of minutes for us to do these exercises. I'm going to give you 2 minutes just to work on them, then we're going to solve them here. Relatively simple. I believe we've actually done some of these. Give you guys a minute to try this out. You've got math jokes. Did we say that the bonus was going to be for this session, right?
Yeah, we actually said last time, but
yeah. So I mentioned that we were going to have, I was going to give bonus points if you guys brought some math jokes. So let's do this. And thank you for reminding me, because again, I've got baby brain. Let's do this. Let's do these 2 exercises. After that, we'll do the math jokes if you've got them, and I'll take note for the extra points, and then we'll continue. But yeah, thank you for reminding me. The jokes, the batter. Nothing can compare to the Bermuda Triangle, I think. Yeah, they're worse. I'm anxious to. I'm anxious to hear them. Let's do these, and I'm gonna walk through them. Let's do A first. And so this is the way I'm going to be doing them here. You don't have to necessarily do them this way in your homework tests or in the exercises. But I'm just going to do them this way here, so it's recorded, and you can have a complete procedure. So I'm going to draw in blue what I'm going to call the base function. Meaning, if I look at y equals x squared plus 1, the function that's based on is x squared. So the base function is going to be a parabola. I'm just going to draw it here like this. And this is equal to y equals x squared. Now I'm adding a 1 to the x squared. And so that means that I am going to generate a vertical shift. So I'm adding a 1. Since the 1 is added, then the shift is going to be upwards 1 unit, and the parabola is going to look like this. And remember that there's certain terminology that we're going to be using here. Notice that it says sketch the graph. Okay, it says sketch the graph. So sketching means we're just doing an approximation. This isn't a precise graph with precise points or anything like that. It's a sketch. If I were to say it in Spanish, it's a bosquejo. Okay, it's a sketch. It would be different if I asked you to plot something. So plotting means that I need to calculate coordinates and locate these coordinates. But what we're doing right now is that we are sketching. Now, let's see B. So in the case of, well, let's do this. This is A. We can do them in the same. Let's do a bunch of them in the same graph, so we don't have to use how many graphs there? 2, and that way they should all fit. So now we're gonna do B. In the case of B, it's the same thing, y equals x squared, so the blue is going to be the reference. But now we are, now we are subtracting 1. And so that means that there's going to be a shift downwards to, in this case, -1. And that would mean that the parabola is going to go something like this. Okay, so B is going to be the pink. A is going to be the purple. And both of these are shifts, vertical shifts. This is a shift upwards. And this is a shift downwards. Okay. Now let's look at C and D. Remember, if anybody here or at home has any questions, then please let me know. If we look at C, the base function is still y equals x squared. However, now we've got something that's being added. And remember the tip that I kind of try to tell you guys, where we're adding or subtracting inside the function. So now we're adding 1, but it's inside the function. So if it's inside the function, we're going to have a horizontal shift. So this is going to be a shift. According to what we talked about, the shift is going to be to the left or to the right? The answer was, is it going to be to the left or the right? It's going to be to the left. So left or right? Left. So in the vertical shifts, it's easy because plus is up, negative is down.
Okay. I don't know which one is right, and like my hands. I still need to look at my hands. Yeah.
Oh, but with regards to the screen or in general? In general in life. Okay, we need to pause here then.
When I'm driving,
We need to pause here then.
I need to look at my hands.
Are you with which hand do you write? Your right hand. Okay, so just remember that the hand that you write on, a few ways to remember, the hand that you write on is right. The hand that you don't is left.
Is that I still need to look at my hands?
It's you need the reference. Okay, it's okay. You need the reference. And the left is going to be the side with the heart. The right is the opposite. So this is going to be for the graphs. If it's a vertical shift, the plus is up, the negative is down. If it's a horizontal shift, the plus is to the left, the minus is to the right. So this is going to be a shift left, and
So plus to the negative and the negative to.
yeah, it's kind of like inverted. Yes.
So to determine if we shift to the left or right, it has to be parentheses.
It has to be inside the base function. Okay.
For example, it could be like x plus, I don't know, so like the number 35, and in parentheses square.
So for example, if I have x plus x to the 3/2 plus 35, this is going to be a shift up. But if I have x plus 35 to the 3/2, this is going to be a shift left. Okay. What Arturo was asking was if how do I identify if it's a horizontal shift? In this case, the number that we're adding or subtracting is contained within the power function. And therefore, yes, we usually have a parenthesis or something that's delineating that. Okay, so in this case, the same, the base function is gonna be the parabola. Again, I'm gonna mostly always try to draw that one in blue. And there's gonna be a shift left to -1, and that would mean that the parabola would now be moved. This would be C. And now for D, the same, the base function is y equals x squared, but now we have a -1. I'm going to put that with, what color should I use? This is the yellow mark. -1. And that would mean that we would have a shift to the right. And so we would have a 1 here, and the parabola would go something like this. We'll be doing a bunch of exercises like these, and there's a bunch of these exercises as well in the next workshop and homework. Now let's look at well, before we move on to the next example, any questions either here or at home with these 4 examples? We good? Okay. Now let's look at example 3. So sketch a graph of x plus 1 squared minus 1. So what we're going to do here is I'm going to do this in steps instead of putting everything on one graph. Yes, of course. So first, the base graph or the base power function is y equals x squared. So that's this one that we've got here. Next up, and the order in which we do these doesn't really matter that much. Next up, we are going to have y equals x plus 1 squared would be the next part. And so if I've got a plus 1 inside the parentheses, this means that we're going to have a shift to the left, and so that would mean that we would have the parabola like this. Next up, we are adding we are subtracting y equals x plus 1 squared. We are subtracting -1. So to the one that I had previously, now we're going to shift it down 1 unit. So we had this one here, and we had originally the -1 here. And so that's going to mean that now the parabola is going to cross in this point here, which is -1 and 1. Okay. And the pink one would be the complete shifted graph. So first we shifted to the left and we shifted down. We could have done this in whatever order we wanted. We first could have shifted up. I'm sorry, we first could have shifted down and then we could have shifted left. We're going to get the same result. This would be a shift down. Yes, go ahead, Ben.
For example, like graphing parabola, it's like easier because like we know which is the point that it's referring to.
Mm-hmm.
But if we were to I don't know, like graph like a squiggly line or something, like, what is the point that we need to, like?
That's a good question. So what Daniel is asking, right now, we're doing a parabola, and in a parabola, we know the vertex. And we're gonna be talking about parabolas and vertices and all that in a few topics, but we know the vertex. And actually, if you notice, in all the cases, we're moving things with regards to the vertex, because that's our reference point. Actually, if we were graphing anything, I'm gonna see some examples of those. You can literally take any point as a reference. Okay, so let me take a screenshot of this, and let's do a weird example, kind of like what you're thinking. This is an unscripted. This is an unscripted example. Before we do that, questions with this one. Before I jump over and do some.
Me, teacher.
Go ahead, Luis, please.
The part of worded shifts, it's part of the.
Remember, if you're participating, if you can turn on your camera.
The shift, like you indicate where it shifts, is part of the final answer. Like, do we need to put that in the procedure?
Oh, good question. No, I'm doing these procedures step by step, so you have a complete procedure as to how we get to the final result. The final result in the case of example 3 is the pink graph that I indicated at the end. Okay. Now, you don't have to indicate the shifts or anything like that in the procedure. However, if you do, the procedure is complete as well. Okay. So if you were to answer all of these steps in the exam or in the homework test, it would be correct. If you just give me the last graph and it's correct, it's correct as well. But it's always good to have a procedure.
All right. Thank you.
Okay, good. Okay, let me take a screen save of this. Now let's do a weird example, because Daniel's question is a good one. So I've taken a screenshot of this. Remember something, you guys, just so for when you're doing your homework tasks or studying for the exams, or remember, number 1, all of the PowerPoint materials are in Blackboard and they've got a version. So after each class, I upload the updated version with all of these scribblings. Okay. So today, for example, I don't know in what version we are in Unit 2, I think version 3 or 4 or whatever. There's going to be version 5. And that version 5 is going to have these notes. Okay. I'm saying this because these are references for you guys to study. So for example, Luis's question is very valid. It's like, do I have to do all the procedure? No, you don't have to put all the procedure. But if you don't remember how to do the procedure is in the slides. Number 1. Number 2, the videos of the classes are updated every session as well. So the video of the class with the explanation is already going to be in Blackboard later today. I'm just saying this so all of this information is there for you guys, as well as the workshops. The workshops, what you do in the workshops, but I also upload the solutions to the same problems but that we did last year. So you've got 2 versions of them, and you've got the recorded version. Okay, so just to remind you that all these things are there as a resource. Okay, let's do a weird example. This is dangerous, you guys. This is unscripted. It's very dangerous when you try to invent a problem because you might invent it incorrectly. So let's see if we can answer your question, Daniel, and not generate more confusion. So let's everybody cross our fingers. I kind of know what I'm doing, but maybe I don't. Let's assume that we've got a weird graph, like you mentioned. I'm gonna draw it like this. And I'm gonna, whoops, that's not. If I need to align this with the whiteboard, that's why my lines aren't correct. Let's say that we've got a function, and I'm just gonna draw it like that. Okay, it's a weird function. First off, question. This has to do with the exam. Question, let's see. I want to check that the people at home are not asleep. let's see. Let's see. Let's see, Miguel, are you there? You please turn on your camera. Thank you, Miguel. Question for you. I just drew
Yes.
something there on the screen. It's that.
Yes,
Is that a function? Yes or no, and why?
I think not, because if you put the line like right over where it goes down, should count. I don't know.
Could you say that again?
Like if you draw a line like exactly down where your cursor is,
Mhm.
wouldn't that be crossing a lot of points in the line?
Oh, so you're mentioning if I do this, what you're saying is that if I do this, it's gonna be
Like, yeah.
touching more than one point?
I think so.
Okay, let's. So you remember the definition of a function, that's important. If we do the vertical line test, we shouldn't touch more than one point. So maybe what I drew wasn't that. Let me do something more than like this. Does that seem to be a function?
Yeah, I mean, should be.
It should, because apparently we're not touching more than one point there.
Yeah.
Okay, good. Thank you, Miguel. It's important to remember the definition of a function. So let's assume that that's a function, okay? And I'm going to call that, thank you, Miguel. Good job. I'm going to call that f of x. I'm going to call that y equals f of x. That's the function. By the way, we don't know the mathematical model of that. We don't know what type of function that is. We're just going to define that this is a function. And now I'm going to give some exercises here. Exercise A. We want to find the graph of f of x plus 3. We want to find the graph, sketch the plot of f of x minus 4. And the graph of f of x plus 1 minus 2. We're going to find those graphs based on that. I think that in the homework test, there's some exercises like this. Okay, so we kept it up to this point. We don't know the function, but we've got that, and we need to do some sketches here. Let's try to do. I'm going to give you a couple of minutes to try to see what you can do with this, and then we're going to solve it here. Okay. So we're going to do each one of these and try to sketch the graph. Try to give it a shot in your notes. Do that. Okay, let's see how we can start doing this. Let's do A. I'm gonna try to do this interactively. So in the case of A, it says that it's f of x plus 3. What does that mean? If we're saying f of x plus 3, what type of
Shifting up.
it's shifting up, correct? Lost my- F of x plus 3, it means this plus 3 that we have here is a shift up. Okay, so let's see how that would happen. So I'm going to do it here. And then I'm going to try to draw it again, but let's assume that we've got this, graph here, and we're doing a shift up. And we're doing a shift up 3 units, okay? So literally what we would do is that this graph, we would move it up. The reference that we've got here, we don't know exactly where that reference is crossing. We would shift this up 3 units. Let's put a reference here because we do need some sort of reference. We do need some sort of reference points. Let's take a couple of reference points here in the graph. And things that we know. We know that the graph crosses here in 0 in these 2 points, okay? So if I'm going to shift it up, I'm going to grab these 2 points here and I'm going to move them up how many units? 3 units over here. Okay. So imagine now that we've got a new imaginary axis. Let's imagine that now we've got a new imaginary axis here. And now these points would cross in that imaginary axis. So now what we would have is kind of something like this. Okay, so we took the 2 reference points that we know are in 0. Now those 2 reference points have to be 3 units up. Okay, why did I choose those 2 reference points? Because they crossed at 0. So it's easy to know if they're 0 and I move them up 3 units, I know I'm going to be at 3. I could have actually chosen any point, but since I'm not giving you any information about any of the other points, if I ask you, what is this point here or this intersection? We don't know, right? What are any of the other points? We don't know them, okay? So we take any reference and we move, okay? Is that one clear? Yes, Arturo, go ahead. Can you say that again louder? I'm sorry. If we were to move
The
the,
one that's on the bottom, the one you don't know the reference for.
uh-huh,
Under the bottom, maybe move that one up, and move the whole graph up to 3. Like 3 spots.
well, the thing is that we really, I didn't mark what value this is. So imagine that if this value were -1, for example, then you would have to move that point 3 units up, and you would have to put that point in 2. -1 plus 3, 2. But I don't know if this point is -0.5, -0.2. I didn't give you that value. Okay.
For example, if it was, for example, -1, you would move that one instead of the whole.
You could use that one. If you knew that intersection, you could just move that one up that amount of units.
So to be sure, it's preferable to move the ones that are crossing 0.
It's preferable to move the ones that you kind of have a reference for their value. Okay. In the examples in the homework test that are like this one, they're not as broad or open-ended as this one. They do give you certain coordinates, and so you know how to shift. Okay, so that would be the shift upwards. Is that clear for the first one? This would be A. Okay. Questions with this one before I move on. Over at home, are we okay? Are we awake?
Yes, teacher.
Let me take a screenshot. I'm sorry, take a screenshot of this. And now we're going to do B. Oops. Here we go. Now let's try to do B. What are we seeing in B in this case? It's a shift. What type of shift? Well, but where is the value that I'm shifting? Remember about the inside or outside. Over here, we have the function and I'm adding 3 to the function. Over here, I'm including or subtracting 4 to the value I'm putting in the function. Okay, so what type of shift would this be? It would be a horizontal shift. And in what direction? To the right. And so if it's a shift to the right, we can again take the reference points that we had. Actually, in this case, I can take the 0 reference point. Now I can take this point here, for example. I don't know the value, but I do know that now that point is going to be moved 4 units to the right. So now I'm going to have, let's say that the 4 is here. I'm going to exaggerate a little bit. And so that would mean that now I have a new vertical axis. I'm going to try to do this here. I'm going to do this. So now the graph would be shifted towards this side. Okay, 4 units. And again, I take a reference point. Okay, is that clear? Okay. Questions with this one? Over at home, are we okay? Is that clear?
Yes.
Okay, thank you.
Teacher, I didn't understand.
Okay, Andres, I'm gonna walk through it again. In B, notice that the -4 is inside the parentheses of the function. Okay. The difference between B and A, Andres, you notice that in A, the number is outside the parentheses of the function. You see that
Yeah,
difference?
and in B is inside.
It's inside. If it's inside, it means that the shift is going to be horizontal. Okay, so the movement is going to be horizontal, right, Andres?
Yeah.
And so how many units am I going to shift it? 4 units. Since it's negative, remember that if it's negative, the shift is going to be to the right. Okay, so what have I done? I've grabbed the function and I've moved it 4 units to the right.
Oh, okay.
You see that?
Yeah.
Now, what do I put as a reference? I'm going to take this point here, and now this point here, instead of being here, it's going to be in 4. Okay?
Yeah.
You see that, Andres?
Yeah, thank you.
Okay. Okay, good. Additional questions before we do the last one. Last one is funkier. Okay. I'm gonna erase this. Now, what's happening with the, what's happening with the last one? In the case of the last one, we have a couple of shifts there. So first off, we can do this, these however we want. We can do them, we can do them in whatever order. But first, I'm going to do it this way. First, this -2 that we have here, what is this going to represent? A shift downwards. Okay. And what is this +1 going to represent? A shift horizontally to the left. Okay. So basically, I'm going to do this in 2 steps. Okay. First, I'm going to move I'm going to move it down 2 units. So I'm going to say that the -2 is here. And so that means that we've got a new horizontal reference. Okay. So that's the new horizontal reference. This would mean that now this would be going something like this. Okay, so I've shifted it down 2 units. Okay, and then I'm going to shift it to the left 1 unit. So I'm going to assume that I'm gonna exaggerate as well. I'm gonna put it. I'm going to exaggerate here. I'm going to say that the -1 is here. So that is going to be now the new vertical reference. And so that means that now the graph is going to be shifted towards this side. And it's been moved to this side here. Okay. And so even if we don't know the mathematical model of the function, the movements, we need to identify the shifts. And again, if the number is outside the function, the shift goes up or down. If the number is inside the function, the shift goes left or right. Okay. Yes.
I have something like what I'm watching right now that is really high.
Mhm.
For example, on that one, 1 - 2, you could rather just apply the -1 and the -2, just apply it and make that your
The new reference.
instead of
Correct.
everything right there, just put that one as your 0.
Correct. So what Arturo is saying is that's a good hack. So I'm going to write it over here. So what Arturo is saying is that we identify that there's a -2 and a 1. The -2 is the shift downwards. The 1 is the shift to the left. So this actually gives us a coordinate. This actually gives us a coordinate which is -1, 2. Okay. And so what's happening is that -1 and -2, -1, -2. -1, -2 is going to be our new 0.
Yes, but what is the point that will go in the -1 and -2?
What is the point that would cross the -1 or -2? We don't know that because we don't know the values of the function. What we do know is that imagine that instead of moving the function, what you've moved is the axis. Okay, so instead of the axis being this one here, now the axis has been moved to this new coordinate, which is the -1, 2.
So that would be like a 0.
That would be like the new 0. So now what we do is that the graph if we try to copy the other one, it would go something like this. So that's another way of seeing it. So we are either moving the graph or we are generating a new zero where we've moved the Cartesian plane, okay? Either of those are correct, okay? We're gonna call this Sosa's method. We're gonna call this Arturo's hack. And both of these are completely valid, okay? So it's actually just different approaches of looking at the same way of doing the problem. Now, going back to Luis's question, in the homework task or the exam, you can use whatever method you want, okay? The thing is for you to get to the correct answer, number one. And number two, if you don't get to the correct answer, at least if we're gonna be reviewing it, to try to understand the procedure, okay? Yes, go ahead. Okay. Questions with this one before we move along. It's Sosa's method and Arturo's hack, and this is the Daniel function. Daniel function. Yeah. I'm gonna go, whoops, I'm gonna jump over here to the PowerPoint. Okay. So the next homework task, I'm sorry, has to do with these with problems related to these. Let's listen to the math memes. Are these verbal jokes or can you or are they graphical jokes?
Verbal, right?
Okay, let's see. Let's do a quick pause here. Everybody turn on your cameras.
I think Algebros has 3 jokes.
Algebra has 3, that's good. Let me just jot those down. Okay, let's see, who wants to go first? So mention your house so I can write. So I can write these down. So Ivan, you wanna start off? Go ahead. And I'm gonna because we're a bit far from the mic, so I'm gonna repeat it, but I'm probably not gonna repeat it as funny as each of the class members. So Ivan, go ahead.
Teacher, what do you call someone who really likes tractors?
Okay, the question is, what do you call somebody who really, oh, house first. Jokers. Oh, that's appropriate, of course. Us jokers. What do you call somebody who likes tractors? What do you call somebody who likes tractors?
A protractor.
A protractor. Okay, good. Wow. Wow, that is going to stay with me for the rest of the day. Good. Okay, thank you. Everybody put a reaction like we're extremely laughing. Everybody. And thank you, good job, good. Thank you for the reactions. Good job, Ivan. House Jokers has some extra points there. Good job.
What is a protractor?
Yeah, they've got weird names in English. It's the
La escuadra.
Protractors?
La escuadra de cálculos.
I think it's what's called the squadra. It's used for measuring angles. Okay, that's a protractor. Okay, good. Good. Okay, who else has got something to share? Go ahead, Arturo.
Mine is horrible. Okay, it's okay, we don't know.
It's for educational academic purposes, not for anything else. Go ahead.
Why are obtuse angles so depressed?
Why are obtuse angles so depressed? Go ahead.
Because they're never right.
Because they're never right. Boom, wow. Okay, that's gonna leave a mark. Okay, good. House algebras, ouch. Okay, this one was, ouch, okay, right. Okay, good, okay, we've got a couple here. Anybody else? Daniel, go ahead, algebras as
Yes.
well, right? Okay.
Why did Einstein and Pythagoras fight?
Why did Einstein and Pythagoras fight?
They both wanted C squared.
They both wanted, oh, wow. Okay, oh, wow.
Exactly.
Wow. Okay. Okay, somebody asked in the morning, who asked in the morning how my day was going? It's going better. It's going better because of the jokes. It's going better. Let's see, go ahead.
This one, you have to add this at the end of when you say that you are an industrial engineer.
Okay, good, okay.
So I will positive whole number because everything here is material and energy.
Oh, that's one of the romantic ones, okay. Okay, good, okay, good. House?
Then the sign.
Everything, oh, wow. Wow, I just want to make a comment on that, on this semester. We may see each other next semester, I don't know, for a course that's called data analysis and organization. I usually give, in this semester, the extra points I give are for the Halloween thing, because that's the kind of holiday this semester. But next semester, I give points for Valentine's Day. And what you have to do on Valentine's Day is that related to the course that I'm teaching, you need to do a poem. Kind of like, and the results have been very interesting because some of the poems have been very, how would you say, uncomfortable. But yeah, that's gonna be an activity for next semester. Yeah, because they have to do with the class. So good job. Any additional one before, another one, Daniel? Go ahead.
It's like the answer is going to be on the. So. What do you call a snake that it's exactly 3.14 feet long?
Oh, a python, yeah. Okay, good.
But the funny thing is, when I told this joke to Turi, he said, "Pie snake."
A python, yeah, that's valid as well. Okay, good job. Anybody else at home? Anybody have something to share? Nobody? Okay, so I'm giving extra credit. Let's do this. Let's do this. Yes, but it has to be a joke that has to do a joke that has to do with math. Okay.
It has numbers.
Go ahead.
Okay. John has 32 candy bars. He eats 28. What does he have now?
Okay, again, say it loud because I'm gonna repeat it. John has 32
2 candy bars.
candy bars
He eats 28.
and he eats 28. What does he have now? Indigestion?
Diabetes.
Diabetes. Oh, that gets cruelty points. Okay, house, Leo?
Highway.
Oh, okay. We're gonna, if you guys have, I'm gonna give you guys points for the jokes. Let's do this periodically, and if you guys find.
I have a meme, but I don't know it. I have a meme.
Let's do this, Daniel, because we've got a bunch right now. Let's try to do this every couple of weeks. So let's accumulate them, and let's spread the joy every couple of weeks. So, for example, Alfredo, I know his day just got his face. He's so smiling because of the jokes. Anna, I don't know if Anna is smiling or not. I think she's smiling. Her eyes look like she's smiling. Marco, definitely. Andres is he's thinking about the jokes. He's meditating on them. We don't know if Luis is smiling or not because he's like a silhouette there, but he's like, there we go. He's smiling. Yeah, good. We'll see what happens. Okay, I'm gonna jump back here. Let's do that periodically. I think that'll be fun. The better the jokes, the better the reaction. Okay. Good. Now, let me switch to the other, camera. Okay, now another thing that we're going to analyze are what are called reflections. Now, we've talked about what happens when we add or subtract a constant to a function. Now, what happens if we incorporate a negative value to the function, out either to the whole function or to the value that's being given to evaluate in the function? And so these are called reflections. And basically a reflection, imagine that these are called reflections, but I use another term to kind of remember what they are. And the term I use to remember these is that I call them flips. That means flipping the function. So if I have a function and I multiply it by -1, I'm basically going to flip the function around the x-axis. Okay, I'm going to flip it around the x-axis. If I multiply by -1 the value that I'm giving the function, or whatever is inside the function, then I'm flipping the function along the y-axis. And these are examples, assuming that I've got y equals f of x, kind of like the Daniel example that we made. This is a function that we've got. We really don't know the model of the function. If I multiply the function by minus, I'm basically flipping the function along the x-axis, meaning that imagine that the x-axis can turn. We are kind of rotating and making the function go on the other side. Okay. If I multiply by -1 the value that I'm giving the function, meaning the minus is now inside of the function, then the flip is occurring around the y-axis. Okay. And so these are what are called reflections. It's whenever I apply a negative value or multiply the whole function by minus. And basically mathematically what's happening, if I've got the function and I multiply it by -1, it means that all of the values that I get from the function have now changed signs. So if the value of the function was 2, and I'm multiplying the whole function by -1, then that 2 is now going to turn into a -2. And that's why the function is being flipped around the x-axis. The positive values of y turn into negative values, the negative values turn into positive values.
Like seeing yourself, on.
Yeah, it's exactly, that's why it's called a reflection. So imagine that you're putting, it's literally, that's why it's called a reflection. Imagine that for the first case, imagine that you're putting a mirror, the blue that I'm writing down here, imagine that you're putting a mirror in that axis. So that's why it's being reflected. In the case of the other one, imagine that you're putting a mirror on the y-axis. And that's why these are called that's why these are called reflections. So now let's look at, let's try to sketch the graphs of the following functions and see what we get. So we can practice this concept of a reflection. First, let's do A. And again, I'm going to be doing it step by step here in these examples. But you can use any other techniques you want, or maybe you can skip some values. So first off, I need to identify the base function. So the base function here, the base power function, is y equals the square root of x. And I know that the base function, if we look at that slide is at the beginning of the slides of this PowerPoint. I'll tell you specifically what slide it is in a moment. That's the slide that has all of the models of the function is slide 27, 26 and 27. Those two slides give us the models of the functions. So we're talking about a square root. If I graph a square root, it looks kind of like this. Now, in the examples I'm giving here, again, just so you remember when you review this and you look at the videos, I'm always drawing in blue the original base function that we're looking at. Yes, Leo, go.
Are you writing the one that is in the negative?
Oh, I haven't done the negative yet. First, I need to identify what the base function looks like. So if I look at A, what do I see? I see a square root of X. So first I want to know what a square root of X looks like. And it looks like that. Now we're multiplying it by a negative number. So let's see what the negative number multiplication does. Now we are adding the negative to the base function. And what happens here is that now I'm adding the negative. And the negative is multiplying the whole function. And since it's multiplying the whole function, what's going to happen is that it's like I'm putting a mirror in the x-axis and I am flipping the function. So the original function was over here on top. The new function is going to be over here on the bottom. It's like I flipped it. Or going back to Daniel's comment about the pond, it's like having a reflection of the function along a mirror.
Is it a coincidence that the reflection and the normal one make a parabola?
No, it's not. No, it's not. That's a very good observation. Y equals the square root of X is a function of X. I'm going to take a brief parenthesis to address what Daniel mentioned because it's interesting. Y equals the square root of X. This is a function. This is a function of X. But what if I grab this and do the following? I'm going to elevate to the square on each side. So y equals the square root of X. I'm going to elevate to the square on each side. And what do I get? Y squared equals X, or X equals Y squared.
Oh,
This is not a function of X. This is a function of Y.
it's a parabola.
So it's a parabola, but it's a parabola in what? Whoops. It's a parabola in Y, not in X. Okay, it's a parabola, but it's a parabola in Y because it's not a function of X, it's a function of Y. So when we do this, imagine that, I'm going to say a very silly analogy here. Imagine that Y equals f of X, and I'm going to give this example because I think you're going to understand it, Daniel, and hopefully others of you are going to do as well. Right now, we're talking about f of X. All of our functions are of X, so we're looking at the Cartesian plane, vertical, horizontal. That's the normal universe. If we flip it like this and convert it into a function of Y, that's a multiverse where now we're looking at the function the other way around, okay? And now instead of the function being of X, now the function is of Y. So it's kind of like now we're doing this, we're we're looking at the Cartesian plane horizontally. Okay, but that's a good observation. If we join these two, sorry, it's the upside down. It's the upside down. Yeah, that's a better example, actually. Better analogy. If we join these two, we get this. And at the end of this unit, we're going to be talking about functions of y instead of functions of x, and how those can be done. And those are what are called inverse functions. Okay. Questions with this one? Okay, now let's do B. Let me just click screen save here. Now let's do B. Now for B, what we have is that the minus is within the function, or the minus is the value that's being given to the function. So now we've got y equals the square root of x, that's the base function, but now we've got a minus inside the function. And so this means that now it's like we would have put a mirror on the y-axis. And the flip is now going to occur along the y-axis. And so this would mean that now, instead of the function going this way, the function is now going to go this way. Okay. Imagine again that we put a mirror and we flip. Actually, that if we were to talk about parabolas, this parabola would be x equals minus y squared. So it's a parabola, but it would be flipped on this side. The upside down. Yes, Alfredo.
Restroom real quick.
Can you say that again? I'm sorry.
May I go to the restroom?
Yes, of course. Remember that we're going long, so if you guys need to get a drink of water or go to the bathroom or anything like that, please go ahead. Okay.
Teacher,
Yes.
I'm going to.
Yes. Go ahead. Okay. I'm going to go then. Questions with this one before we continue? Nope. Okay. I'm going to go to the. Jump over to the next one. Now we're going to talk about stretches and compressions. So first we talked about something adding or subtracting to the function. Now what happens if we multiply by something in the function? Actually, multiply or divide, because we're going to be talking about or incorporating a constant that we're going to call this constant C. If C is larger than 1, this basically means that I'm multiplying. But if C is between 0 and 1, this actually means that I'm doing a division. Okay, because if I'm multiplying by 0.1, it's the same as saying I'm dividing by 10. Okay, but just to be clear, so for example, in this case, C would equal 2. Yeah. Over here, for example, C would equal, I don't know, 0.2. Okay. And what happens here is that if I'm multiplying by a value that's larger than 1, it says that the graph is being stretched vertically. So again, this is the way that I try to explain this, or I try to understand this. And this means that for the first case, for this one, stretched vertically means I am pulling the graph. So imagine that the graph were a string. Imagine that the graphs were strings. Imagine that you're grabbing the string and you're pulling it. That means you're stretching it. By pulling it vertically, the only thing that that means is that the graph is going to try to get closer to the y-axis. It's going to try to get closer to the y-axis. That's if the value is larger than 1. If the value is between 0 and 1, or a fraction, that means that compressed vertically, this means that I am pulling, but I'm pulling it horizontally. Okay, so that means that the graph is going to get flatter towards the it's going to get flatter towards the y.
Is it stretched? Like they're pulling or compressed side?
Oh, that's a good observation. Both references in what's written here is vertically. So stretched vertically, compressed vertically means stretched horizontally. They're opposing terms, okay? So pulling horizontally means I'm compressing it vertically, okay? You get it? That makes sense. So if I'm pulling something, it means I'm squashing it, really, if I'm pulling it horizontally. So the stretched vertically, the pulling like that, another way of saying is that it's compressed horizontally. So compression and stretched are opposing terms. So let's talk a little bit about how that would look. I'm going to jump over here to the whiteboard. So let's give an example as to compressions here. I'm going to take whatever base function. I'm going to say y equals x to the 3. Okay, y equals x to the 3. The graph of y equals x to the 3 is something like this, if you remember. Now let's see a few examples about what compression and stretching means. Let's see here. Let's see here. Fernanda, you there?
Yes, teacher.
Hi, Fernanda. What are you studying, Fernanda?
Industrial engineering go program at CETIS.
Boom. Boom. That must be really difficult.
Oh.
Good job. And that means that, and you must be really, really, really smart. Perfect, perfect. You guys are really learning this stuff. Perfect. I'm going to let you go for now. Give me a number that's larger than 1, whatever number you want.
5.
5, perfect. Thank you, Fernanda. You are free. Let's assume that we've got now y equals 5 times the original function. What does that 5 do to the function? Well, the 5 is going to do, imagine that we are pulling the function vertically, okay? So pulling it vertically only means that it's going to try to get closer to the y-axis. So I'm gonna do this, by the way, I'm gonna exaggerate this a bit more, just for the purpose of the example, just so it's clearer. I'm gonna do this. I'm gonna exaggerate, whoops. I'm gonna exaggerate this a bit more. And so pulling it would mean that it's going to try to get closer to the y-axis. So imagine that I am grabbing this is the hand. I'm grabbing it and the hand is pulling it upwards. And so that would mean that the graph is going to be a little bit closer to the y-axis. The larger the number, the closer to the y-axis. Okay? The larger the number, the closer to the y-axis. By the way, in the exercises that you're going to be doing for the homework test and for the exam, these are sketches. So if I say 5 times x to the 3, I'm doing a kind of proportion there. Okay, it's not exact. Okay, because we're not doing a plot. Okay, the only thing that you should show is that there was a compression. Okay, so so you should show that. Now let's see. Let's see, Alfredo. Are you there?
Yes, teacher.
Alfredo, can you please turn on your camera quickly, please? Okay. Hi, Alfredo. Good afternoon. You there?
Hi.
Okay. Okay. What are you studying, Alfredo?
Industrial engineering global program in CETIS.
Yes, you are correct. That must be really difficult, right?
Yes, it is.
Good. To the point, it is. I like it. We're not playing around. Good. And you must be really, really smart.
Something like that.
Don't lie, don't.
Okay. Well, I didn't hear the last part. What did you say?
Something like that.
Oh, good, good. That's variations. Listen to these. These are variations. That's good. Give me a number, Alfredo. Good job, Alfredo. Give me a number between 0 and 1. Any number. It's a fraction, basically. Any number you want.
0.1.
0.1. Good. Thank you. Perfect. So now let's assume that we've got the base function. It's y equals 0.1 x squared. That's basically what, Arturo? Yeah, what would happen there is that the 0.1 is going to generate now that the graph we are pulling now, but we're pulling it horizontally. Okay. So now imagine that for this one, we've got another hand over here that's doing this. And so that means that the graph is going to try to flatten towards the x-axis. So it's going to, first off, it's going to get further away from the y-axis, and it's going to try to get flatter. Whoops. It's going to try to get flatter towards the y-axis. Okay. It's going to try to get flatter towards the y-axis. Depending on the value, so that's 0.1, that's a small value. So it would have been different. We said 0.9, 0.8, etc. It's going to be how flat it's going to be. Okay. So these are examples of stretching and stretching and compressing. Okay. Questions with these? Yes, go ahead.
How do we determine if we're pulling it or it's not pulling it?
Good question. If the number is larger than 1, you're pulling it vertically. If the number is between 0 and 1, you're pulling it horizontal. Now, what we mentioned, the 0.1 that we just wrote down there, the 0.1 that we just wrote down there is equivalent, and to explain why we're doing that, or what does it mean that it's less than 1. So we've got y equals x to the 3. The 0.1 that we just talked about is multiplying here. But actually, multiplying by 0.1 means that I'm actually dividing by 10. So anytime I have a fraction, a number between 0 and 1, I'm actually dividing by something. And that's why the division is making it get closer to the x-axis. Yes, go ahead. Okay, questions with this one before we keep up.
So, teacher.
Oh.
So it's more far when the 0 point something is larger, like 0.9 is it more far?
Oh, okay. 0.9, let's answer this. Let's talk about this. The original function, Joel, would you agree that the original function is multiplied by 1?
Yes.
So is 0.9, which is closer to 1, 0.9 or 0.1? But 0.9 or 0.1?
Okay.
0.9, right? And so if this were multiplied by 0.9, it would be very similar to the original one. If I multiply by 0.1, that's farther from the 1, then the smaller the number is, the flatter it's going to be. Okay? Yes, but I think, well, Leo, are you gonna let Daniela speak, or you want? You're gonna have to fight. No.
My turn.
Okay, go ahead.
My question was that it was like almost the same as square, that well, it was like when you multiply to a number greater than 1, it gets like smaller, isn't it?
Yeah.
Yes.
The larger the number is, the more you're pushing it closer to the 1.
Okay, but like in any case, sometimes it doesn't matter that if you multiply, it gets like smaller, like
More compressed.
compressed, and if you divide or multiply like for a fraction, it will get like
Flatter. Yes, correct. Yeah. So the only distinction there is that, again, you can see it in 2 ways. Either we're always multiplying by something, but sometimes it's larger than 1, sometimes it's between 0 and 1, or sometimes we're multiplying by something and sometimes we're dividing by something. The division is what's between 0 and 1, and that makes it get flat. Yes, Daniel.
Is there a number or multiplication that will make it completely flat? Or it would make it like, I don't know, like very close to 0?
That in any case, that would be tending to infinite. So the larger the number is, well, we're talking about flat. The smaller the number is, that's what's going to be getting it flatter. So right now we multiply by 0.1. Oh, skinnier towards the y-axis, the larger the number is. So since we can put any real number there, going towards infinite, that's what's going to make it closer to the.
So it could be a line.
Yes. So if we were to go into, again, multiverse math, if this number here that we call C tends to infinite, then we're going to get a vertical line. Okay, if this number here, C, tends to 0, we're going to have a horizontal line. And right now, by the way, that's why I'm talking multiverse math. Right in this course, we're not going to be talking about limits. That's for calculus. But kind of what we're talking about here are limits. If a certain value tends to go towards infinite or tends to go towards 0 or to whatever value, how would the function behave? If C tends to be infinite, we're going to eventually get to a straight line vertically. If C tends to be 0, we would eventually get to a horizontal. Okay. That's actually one of the first topics in calculus, which has to do with limits. Next semester. Okay, I'm going to return to the PowerPoint. Great. Before we do this one, we're going to do this one here. Homework task number 7 is already in Blackboard. That's for next Thursday. Okay, Thursday the 14th. The next workshop is going to be for Tuesday, okay, which are these problems from homework task 7. So these are for Tuesday, okay? Tuesday. Send it to the WhatsApp. For Tuesday. October 12th. And let's do this example, and then we'll wrap up for today. So you have all of it. And remember that Estrella has tutoring today and next week as well. So first off, I'm going to do this one step by step. And so first off, the base function has to do with this square root that we've got here. Okay. And so the base function that we're talking about that we're going to be modifying is y equals the square root of x. If we look at that one, we're going to see that the graph is like this. Okay. Now, how we approach the different shifts, multiplications, etc., we can do them in whatever order we want. Okay, I'm just going to be following a procedure here to do them in a certain order, but you can actually do them in whatever order you want. The next thing I'm going to do is that I'm going to be building the function from scratch. The base function is the square root of x. And then I've got a -3 here. What does that -3 do? What type of shift is it? It's a horizontal shift to the right. And so our new function is going to be here in 3, and it's going to look something like this. Now, I'm going to do as much color coding as I can so you can see the different steps. Remember, you don't necessarily have to do this in all of these steps in the exam or the exercises. I'm just doing it like this so you have the steps. The next is that I've got a 2 that's multiplying all the function. What is that 2 multiplying the whole function going to do? According to what we just spoke about. It's going to pull it. And remember that these are sketches. So these don't necessarily have to be precise. We just have to reflect that. So if the original was like this, and it's located here in 3, the pulling is going to make it a little bit larger. I'm just pulling it upwards. So this was a shift to the right, and this was a pull upwards, or a pull, or stretch, okay? I'm gonna continue over here. Now we've got y equals square root of x minus 3. And now I'm multiplying by a minus. What is that multiplication by a minus going to do to the last graph I had, the last one, the purple one? What did the minus do? It's the flip.
Yeah.
And it's a flip in which axis? X. It's a flip on the horizontal axis. So originally it was here going upwards. Now it's going to be here going downwards. And lastly, I've got following. The last thing that I'm going to add here it's the 2. And what's happening there? Really, if I put this 2 here, or no, because it's outside. This is multiplying all of this. It's the same as if I would have put it over here. Would you agree?
It's ready.
It's yeah, because it's outside. So I don't have a +2 here, but it's really something that's outside that's being added to the function. So really, I'm adding a 2. What is that addition of a 2 going to create? What type of shift is it? Well, let me just write down this here. This was a flip. Well, no, let's talk about this. If I were to tell you that I have f of x plus 2, what type of shift would this be? It's a no. It's a vertical shift upwards. Remember that if the 2 is outside the function, it's a vertical shift. It's the same thing that's happening here. This is outside of the function. So I'm going to have a shift upwards.
So in the
Yes.
first 2 that you use, it's the same as the second one that you use.
Yes,
Yes.
that one is multiplying.
Could you say that again? I'm sorry, I
It's
didn't.
like I got confused because I thought that you first catch the last one, the first.
Oh, let me just, yeah, let me just do this because I didn't think about this and trying not to generate confusion. So we're going like this. We're going left to right.
Okay.
And then, so we're going like this,
That
and
one,
like
the
this,
one in purple,
and
and
then
the second in purple, it's like a kind of a step that is like 1.1 and 1.2.
Uh-huh.
Is it?
Yep. And over here. And so here now, what we're going to have now is that the graph has been moved and it's going to be going like this. And that would be the complete graph of that function. Okay. The homework tasks, problems, and the exercises we're going to be doing have to do with these. Have to do with practicing all of these reflection, shift, etc. Questions with this one before we wrap up? Yeah, the thing that to remember here is that this one is that the -2 is multiplying the function and the 2 is outside of the function.
The equations, like when we were doing equations, that's like, oh my, you have like trying to cancel everything to make it less work.
Oh, yeah, that's like the typical thing you tell a kid, you say x plus 2 equals 4. Please eliminate x, and what you do is just you erase it. So yeah, let's we need to practice those things. Okay, questions with this one then before we wrap up. Okay, then I will see you guys next Tuesday.